Hello everyone, welcome back to another Sokol Devlog video. In today's video, we'll be covering triangles, shaders, and textures. So before we start, I just want to come to this GitHub repository to download the Sokol shader compiler. So to do this, just come to the GitHub repo, go to bin, choose your operating system. For me it's Windows, go to the exe, and just download it. Then in our project folder, I just created a new folder called tools, and I put the executable in there. So before we start, I just want to go over a couple of things. In graphics programming, we want to draw objects to outputs. These outputs can include our screen or render textures. In order to know which ones to draw to, we use parsers. Parsers tell Sokol what we're drawing to. And then we have pipelines. Pipelines tell Sokol how we're going to draw to those parsers. And in our pipelines, we'll have shaders. Shaders are programs on the GPU that run and tell the GPU how we're going to draw to the parse. And bindings are just data that the shader uses. These could include our mesh vertices, textures, or any other data that the shader uses to draw to the parse. So to start, we'll come to our implementation.cpp file, and we include some new headers. We include the graphics header, the glue header, the logging header, and a debug text header in the utils folder. Then in the app.hvp file, we'll include the graphics header with declare 3 new variables: the screen parse, which is the parse that tells Sokol we draw into the screen, the debug score x and y for debug text, and then a new function called debug print, which is taking the input text, the x and y, and the color of the debug text, which will be in RGB. Then in our app.cpp file, we'll include the headers, and then we'll define our 3 variables. Then in the create function, we'll give our sap description the logging function, and then in our init function, we'll init the Sokol graphics environment, and we'll also init the debug text environment. Then we'll define our screen parse. We'll go to colors are 0, which is what will be shown to the screen, and we'll tell the load action will be clear, which means we'll clear the screen from the previous frame, and we'll clear it to black, and we'll do the same for the depth buffer. We'll clear it to 1. Then in the frame function, we'll call the swap chain to swap our parse. We'll begin our screen parse. We'll set the debug scale x and y. And then after the frame callback, we'll draw the debug text. We'll end the screen parse. And then we'll commit the screen parse to the screen. And then we'll define our new debug print function. And then we'll come to our main.cpp file in our demo project. We'll come into the Sokol main function. We'll define our debug x and y. And in our frame function, we'll call app debug print hello world, and we're going to try building that. As you can see, the hello world was printed on our screen, which means Sokol graphics is working. And then we'll just create a new file called shader.hlsl, which will be our shader. It will be a very basic shader. So we'll have our vertex shader, which will take in a position and set it to our geo position. And then our fragment shader will give us a fragment color and make the fragment color to be white. Then we'll define our shader. We'll give it a name. I'll call it triangle. And then we'll get our vertex shader and our fragment shader. Then to compile this, we'll take our exe, give us the input, which is our HLSL file, give us an output, which will just be shader.hlsl.hpp. I'll give it a shader language. And since we set our implementation to use GL core, we'll set our shader language GLSL 430 for OpenGL. Then we can just run that. And as you can see, it generated the HPP file for us. And in here, we're really only interested in the attributes and also the shader description function that it generated for us. And then back in our main.cpp file, we include vector, we'll include our shader, and then we'll create a new struct called vertex, which will hold its position of x, y, and z. And then we'll define new variables. We'll define 2 SG buffers for the vertex buffer and the index buffer. Then we'll define SG bindings for our bindings, which will hold our index and vertex buffer. Then we'll also create a pipeline. And then in this function, we'll create our vertices. These are the vertices for a triangle, and these are the indices for a triangle. And then we'll create our vertex buffer. We'll create an SG buffer description, give it our vertex data and its size, and then we'll call make buffer. And then we'll do the same for our indices. We'll give it our indices, And then we'll also have to set the usage to an index buffer to true. This is telling sokol that this is an index buffer and not a vertex buffer. And then we'll call make buffer on that as well. And in our bindings, we'll give our vertex buffer and our index buffer. Next, we'll make our pipeline. We'll create our shader using the generated shader function by the shader compiler, using sgmake shader and the shader compiler description. And then we'll create our pipeline description. We'll take in the shader, the indices type. As you can see, we use uint16, which is what we'll set to our index type for our pipeline. And then we'll give it a stride of our vertex size, and then we'll set our attributes. We'll set our triangle attributes in our vertex shader to be a float 3 because it takes in a vector 3. So we'll take in a vertex format float 3, and then we'll create our pipeline. And in the frame function, we'll apply our pipeline, we'll apply our bindings, then we'll draw our triangle. We'll take our starting index, which will be 0, how many indices we're drawing, which is 3, and how many instances we want. We want 1. And then we'll try building that. And as you can see, our triangle is now being drawn. And then just for fun, I'll change our shader just a little bit. In our vertex shader, we'll tell it to give us a color, and then we'll check if our vertex index is 0, we'll give it red. If our vertex is 1, we'll make it green, and our vertex is 2, we'll send out blue. And in our fragment shader, we'll take in that color, and we'll set that color to our fragment color. And we can try compiling that. And we're going to try compiling our exe again. And then run it. And as you can now see, our triangle is now colored. Okay, next we'll come to the stb GitHub repo, and we'll download stb image.h. And just download this. We'll be using this to load our images. And in our third party folder on app library, we'll create a new folder called stb, and we'll put our stb image.h file in there. And when we come to our implementation.cpp file, we'll define stb image implementation, and we'll include the stb image.h file. In our shader, we'll change it up a little bit again. It's just taking a position, but now we're also taking a UV. It'll also give us a UV, so it'll still set the position, but now it also gives us a UV for our fragment shader. And in our fragment shader, it's taking a UV, it'll also taking a texture and a sampler, and it'll sample our texture at that UV, and then set that texture color to our fragment color. And in our main.cpp file, we'll include IOStream, we'll include stb image, and in our vertex struct, we'll give it 2 new members, u and v, and then we'll create 2 new variables, sgview for our texture, sgsampler for our sampler, and then in our net function, we'll set a new clear color. I just set mine to pink, and then we'll update our vertices to a quad with the correct UVs, and then we'll update our indices to reflect that as well. Our vertex buffer and net buffer can remain the same. And in here we'll load our image. We'll call stb load to load our image. This is a test image I have in burn.res.aha.png. That's our image. And then we'll create a new SG image description. We'll give our image width, image height, the pixel format, which will just be RGB8, the data, and then the data size. And then we'll create an SGV description. We'll set the texture.image to our image description right here, and we'll set that to our texture view using sgmake. And now for our sampler, we can just create a sampler description. We can leave all the values as defaults, and we just create our sampler using that. In our bindings, we'll set the view 0 to our texture, our sampler 0 to our sampler, and then in our pipeline, we still have our position, but now we also have a new attribute called UV, and that'll be our float 2. And in our frame function, everything will remain the same, except for drawing 3, we'll be drawing 6 indices. And we'll try building that. And as you can see, we're now drawing our texture. It's a bit squashed right now because my image is square, but my window isn't. So if I make it more square, as you can see, our texture is now being drawn. And alright, that'll be the end of this video. I hope you enjoyed, and I'll see you in the next one.